Hello friends, in today's class we are going to talk about different synchronization mechanism. Welcome here, and we are talking about synchronization mechanism, and we are having two different categories. One category is using the software and another category is using the hardware. And we'll need the support of the hardware definitely. In this case we required this will be executed in kernel mode. Now here we have both the cases. We have a mutual exclusion with busy waiting. Here also we have a busy waiting. Busy waiting is what we are, as you can see here, what exactly is a busy waiting. So to demonstrate this, look at this program, right? If while the counter is equal to 0, and then we are putting a semicolon and we are blocking this, not blocking, we are restricting this process, and this is called as a busy waiting. And here also, when we talk about this process, counter is equal to buffer size do nothing, then it is a busy waiting. So that is basically a busy waiting. And so mutual exclusion with busy waiting, mutual exclusion, we have a spin lock. Okay, spin lock, and this is the blocking. So here when we have a spin lock, that is, something like a loop is going on, a loop is spinning again and again till the condition is satisfied, and that we can implement by using software. Here we are doing blocking, that we are not allowing other process to come. Okay, not allowing other process to enter. Okay, and that is something related with the hardware, and it will be done in the kernel mode. So blocking means the major source of switching. Okay, major source of context switching, right? Remember context switching we have done in the previous lectures. So major source of context switching is what? Interrupt. Major source. Even that may be possible that process exit or go for IO, but here the major source, if a process is in middle of the execution, the major source of the context switching is interrupt. So block all the process by disabling the interrupt. Disable the interrupt. Okay, and if you disable the interrupt, then definitely that process will be keep on complete its critical section. Disable the interrupt, let it complete the critical section, then let it have a exit section where it will go and it will set up what? Again it will enable the interrupt, right? So that is the idea of this the hardware part, that disable the interrupt. We can have multi-process and it is in the kernel. So the main source of the preemption is what? The interrupt. Okay, interrupt. So disable the source of the preemption in the critical section, in the entry section, and enable in the exit section. So disable it at the entry section and enable it at the exit section. It guarantees mutual exclusion. No one will come, and always it will guarantee the mutual exclusion because interrupt is disabled. Enabling and disabling of the interrupt is done by the kernels, and by we can use the system call. So that is pure at what level? At hardware level. Okay, at hardware level. And somehow process will look like this, that we are having P1, P2, P3, the process. It disable at the entry, you just disable it, intersection at critical section, you execute it, and then finally you enable all the interrupts. But you need a hardware support for this. Okay. The next is your using lock variable, that is your software mechanism, and it is implemented in the user mode. So it's something like we have already seen while what we have seen is lock variable is exactly equal to 0. I just forgot the name. Just quickly look at this. This one, counter is exactly equal to buffer size, and another one is counter is exactly equal to 0. So that is a variable, and we are just putting a spin lock into this, right? So using lock variables, So it is just example, while counter is exactly equal to, while my variable counter is exactly equal to 0, or it is equal to max size. So we have a multi-process P0, P1 and P2, and this P0, P1 and P2 will be will go into this. At the entry section we will have a lock variables, and if lock is 0 then critical section is free, and if lock is 1 then critical section is in use. So we will have all the lock variable, and lock variable will be shared variable, right? So we are shared variable lock. This is also having a lock variable, this is also lock variable, and this is also lock variable, right? And the one who will have this value 1 will go enter into the critical section. So I will write something like, while lock is not equal to 1. Okay, so that I can write over here as here, while lock is not equal to 0. Okay, if it is true, lock is not, if it is 1, okay, so 1 not equal to 0, sorry I was wrong. While lock is not equal to 0, lock not equal to 0. So if it is not 0, then what we have to do, then we have to do the busy waiting, right? If it is not 0, then there will be a busy waiting, and then we'll make if it is not 0, then we'll assign it to lock variable to 1, that it is false, lock is not 0, 0 not equal to 0, false, then we'll make it 1, then we'll enter into the critical section. On and exit, what we'll do, that will make the lock equal to 0. So that is a lock variables, and using lock variables we can achieve mutual exclusion. Okay, so the next section is that we are going to see here, by that the solution of software solutions, and then finally we'll go to the hardware solutions, software solutions of a critical section. Okay, so that's all for this discussion. Thank you.